We're going to understand the layout and part zone assemblies. Basically, in this topic, we're going to review the layout and part zone assemblies that are created when a moldable part is added to the mold assembly itself. Also, we're going to take a look at assigning material to the mold assembly, and the effects it has on the mold files will also be discussed. There's two files to generally start thinking about. Any file with the _ly for layout or _pz for part zone. These two files are additional files that are created after moldable parts are added to the mold assembly and the assembly is saved. These files are used in the following ways. Any file containing the _ly.im assembly is the top level layout assembly. If multiple different components are added to the mold assembly, an _ly.im file is generated for each unique component. Any file containing the _pz assembly is a part zone assembly in the layout assembly, which contains the moldable part design file. For each instance in a family mold pattern, a PZ assembly is created. We can take a look at our browser here, and we can take a look at displaying the model and expand it as needed. But in this case, we can take a look and we can see that we have the ly file here. Under that would be the multiple patterns used inside of this file that were created, the PZ files. The next step in our mold design workflow is to define the material type. No files are generated during material definition, but a material node is added to the mold design browser. We can expand the material node as needed and look at the various materials that may be applied. To make a change to any material, it's a simple right-click, edit feature, and we now have the ability to choose from our catalogs of information materials and their trade names that we'd like to utilize inside of our design. Next, we're going to examine the files that are generated for core and cavity and mold base creation. Basically, we're going to examine all files that are created in a mold assembly to generate the core and cavity. We will also examine the files created by the addition of the mold base. Take a look at your mold design browser. With the addition of the workpiece, a WP file is generated. So if we take a look at our PZ files and expand one of those, we can see that here is our MP file that was created. The WP file that we are witnessing here is a file that contains a single extruded feature and creates the workpiece geometry. In the cover node in the mold design browser, a workpiece node indicates that a workpiece has also been added. In the model browser, the workpiece file is located in the part zone or _pz assembly as follows. Here's our PZ assembly, our MP, and our WP file. When creating the parting surface, you first create a patch surface and then you create the runoff surfaces. Although no new files are created during this step, the MP file is modified. The only change to the mold design browser displays the patching surfaces and runoff surfaces nodes are now listed in the cover. With the creation of the core and cavity, a core file created and a cavity file is also created. The core file holding an _CR and the cavity file _CV. We can return back to our model browser or our mold design browser also to look under our cover node here and see the other files that are being displayed. In this case, we have our patching surfaces and runoff surfaces that I just spoke about. Let's take an additional look at our _CR file. Here I'll simply open the file and you can see the information that is left for us. By closing this and returning to our assembly, we will also look at the cavity file in much the same fashion. Again, I'll find my CV file for my cavity and also open that. Again, we see what's left in our cavity file. Again, I'm simply going to close out this file to return back to my assembly. Another file type that we'll find in our browser is the _in1. This part file is listed in the cover mold directory as an insert, which was created when the insert was added to the moldable part. The _in1 file is located in the _pz or part assembly. If we switch to the mold design browser display, the insert is included at the bottom of the list in the cover node because it was applied to the moldable part. And here we'll expand our cover and we'll see at the bottom our insert was added. Next, we'll examine the runner system files and component directories. To create the runner system in a mold assembly, you must define the gate location, runner sketch, runner, gate, and cold well. With the initial definition of the gate location, an _RG runner file is created in the cover mold directory. Review the cover mold RGIPT file in the model browser. The RG file is adaptive file, as indicated by the adaptive symbol. So here we can find it in our model browser for this mold assembly file. Here we'll simply select Open on it to take a look at the file itself. The runner appears as shown on the screen. We're simply going to go through and close this file to get back to our assembly. With this file closed, we will look at our assembly and we'll look at the mold design browser itself. Under our mold design browser, we're also going to be able to see places for our runner information, our gates, and our cold wells. Other file types that are generated inside of our designs is when we may use injectors, slider components, spur bushings, locating rings, and lifter components. This information is also displayed inside of our files. If we go back to our model environment and we expand this layout file and look under the mold cover files themselves, we will actually see the ejector pins and other related information applied to these files. Coming back to Windows Explorer and taking a look at our cover mold workspace folder, we can see that anytime we do add those injectors, lifter components, the locating rings, these files are created and all of our library components are stored there with the overall workspace and assembly file that you'll be working on. In our last topic, thinking about our mold assembly files, we need to think about the files that are generated by combining cores and cavities and adding cooling and heating components into our designs. When working with a family mold design or a multi-cavity mold design, the combine cores and cavities command is used to combine separate cores and cavities into one core and cavity. In our assembly, we will find the files that are generated with such activities as combining those two. It's listed for us in our model browser, cover mold _combined, for our cavity and also our core. If we take a look at the mold design browser, we will also see in here a work pocket piece that would be generated. We would use the work pocket command to create an evacuated pocket in the mold base, which holds the core and cavity itself. This command actually won't create any new files, but it does generate modifications to the mold base files. The final node in the mold assembly represents the cooling and heating components, which is comprised of the cooling channel and its components in the mold design browser. If we take a look at this and expand it, the node will display all the channel segments needed for the cooling requirements of this design. Also, these will be represented in our Windows Explorer in much the same fashion. Here's our cooling components and also the information that makes them up.